All right, how you guys doing? We're going to go ahead and take a look at problem set number 1. Now, here are some of the errors and things that I noticed. So go ahead and take notes, make corrections, and fix the things that you need to fix so you don't make some of these errors for the next time. Now, in this student's work right here, we've got this equation, or actually non-equation, where we're saying 1 over p plus q is not equal to 1 over p plus 1 over q. Now, my concern with this is that this piece right here that we've got, where did that come from? There is no evidence that shows where q plus p over pq came from. And if you're trying to combine these two terms right here, 1 over p plus 1 over q, that's not the same as that. So be clear with the work that we're taking a look at here. Now, the next one that we're going to take a look at is this problem here. And I want to really talk about the word it right here. In AP Calculus, you do not use the word it. It could refer to a lot of different things. In part A, now, I don't know if you're talking about this piece works, if it's 2x plus 2h. I don't know if you're talking about this piece right here, the k, or what. We don't know what which side is which. Same thing here in part C, the it. Are you talking about this part right here, or the part on the other side of the equal sign? So be clear with what it is. Now, in this problem right here, this is always a classic one. Take a look at this value right here. Can you tell me what this number is right there? Because it's very difficult to read. And so when reading student work, if a grader cannot read the number or the sentence or word that you're trying to communicate, it will not be graded and you will not earn any points. So be neat about your work so that it can be graded. Now, this is a great example of a problem right here where a student said, to prove this, they used the values 2 and 3 for A and B and showed how the square root of 13 is not the same thing as 5. So that was really, really well done with that. So that's a great technique to go ahead and prove problems when you're not given any particular values for A and B. Now, this student here, when you take a look at this, you don't get bonus points for, doing all your work on one sheet of paper. Like, take your time and show your work one step at a time. And instead of going across with your work, I want you to write your work going vertically, going up and down. So, like, for example, this problem right here should be written a little bit differently. So you start out with the original problem, but below that, this line right here, so you would have A equals B over C plus Z squared. So below that, you would write A and then C plus Z squared equals B. And then this C plus Z squared part, that's actually a linkage error, and we're going to talk about that a little bit later, because when you multiply both sides by C plus Z squared, that would cancel out on that side. So write your work going vertically instead of horizontally. How to show work? Always a great question. Come see your teacher or talk to other classmates before you have to turn something in. Now, this is a problem that is always very interesting to look at, because if you take a look at it, it looks like, yeah, they have the correct answer on this, because you have to talk about the domain for this particular function. Now, what they do is a great job of taking a look right here, setting x minus 10 equals 0, and then I guess they change the 10 to an x right here. Again, be neat about your work. That's so important. You've got to be able to clearly communicate what you're doing. Now, over here, they make a really small mistake. You forgot to put a parentheses right there. So notation is also very important in mathematics. So be sure to communicate correctly using correct notation. All right, so notation is something you always want to be aware of in communicating correctly. All right, now this problem right here, this is a classic one right here. So you have an equal sign right there and an equal sign right there. And because all three of these statements are not equal, then that's what's called a linkage error. In an AP Calculus, you'll have a point deduction when you link statements that are not equal using an equal sign. So be careful when you use an equal sign. So here's an example of a problem that uses linkage correctly, because the first line, log 70 minus log 7, use your log property, you get log 70 over 7, and then the use of the equal sign right there. Those two statements are equivalent as it is to this third statement. So there's a correct usage of linkage and equal signs. Now, here's just a small thing on this one. It's not a big deal, but it's just a writing thing. This should be written underneath. So when you show your work again, do all your work vertically, and that way it's organized in a way for a reader to follow. So that y prime equals 1 minus y over x minus 1, write that underneath the next line. Now here's a problem that shows up very, very often all the time. So you can see right here in this first step, like this person's multiplying right here. Now it's a technical thing, but with a notation, make sure you include that bar that's right there. Now in the next piece, there's no real communication, like what happens from here to here to here. Like there's no flow of, there's no equal sign. It's not really clear what is going on other than how are these, what my question is, how are these three things connected? There's no indication of that. You just have numbers on a paper and letter or variables on a paper. They're just all hanging out, and eventually you get to this piece right here. So organize your work in a way that is easy to follow and is linked correctly. Now here's another problem right here. When you take a look at this, it's really difficult to kind of see what goes with what. Because at first glance it kind of looks like these pieces are all tied together, but they might not be. And another piece too, since you're in Calculus AP right now, I don't want to see this minus one stuff anymore. You guys are well beyond that. I know that if you go from that step right to this step, that you know, you're doing your work correctly. Now the other thing that's challenging with this one is that when you see there we go. When you see this piece right here, you've got this problem right here, and it's being linked to this piece right here. And again, here we're using an equal sign in here, but then in the answer part, x cannot be -1. So again, just keep your work organized and make sure that you use your symbols correctly on this part. And you know, that's actually not the correct symbol, because if you're dealing with 1 plus x being the square root, that 1 plus x part, that could be greater than or equal to 0. Now here's another person right here. When they wrote this work, again, it's all crammed in. It's difficult to read. It's hard to really make sense of anything. It says asymptote at x equals 10, but I don't see 10 anywhere on that picture identified at all. So if you're going to use graphing, make sure that your graph is labeled in a way that is easy for the reader to notice what you're talking about. You've always got to communicate clearly with what you are doing. Now this problem right here, at first glance, like, okay, let's take a look at it. So they take x minus 10 right here, and they set that the argument greater than 0, and then they get x is greater than 10. That's awesome. Now look at what they have written here, and then look up here. It's a small thing, but look right there, a negative sign. So be careful, make sure that you're accurate in what you're writing down and that your work matches your answer. Now here's a problem that showed up on quite a few papers right here. This problem actually makes, this person actually makes two mistakes. One, you've got the capital letter A and the capital letter B, and those get changed from capital letters to lowercase letters at different points in the problem. So whatever variables they give you, keep the variables the same. Don't change them to different variables unless you declare that. And that's not done so here at all. So keep the letters the same as you work throughout this problem. Now the other mistake that they made is that, and they did not recover from this mistake, they took a look here, and when you take the square root on the left-hand side, you've got to make sure it includes a plus or minus on that side. Now they didn't recover it all and add it back in on this step or this step for their final answer, so they lost full credit on this particular problem for those two reasons. Now here's the problem again with writing where a person makes a careless mistake. This part right here is a 1, and then they change that to a 2 right in that spot. So again, you want to be neat enough and organized enough so that you can follow your own work and read your own numbers, because this person made a mistake just in moving that term over to the other side, and therefore made a mistake with that. So make sure you realize what it is that you are writing. Now this person didn't write out any of the original problems for the solutions they came up with. Always write out the original problem and then show the work that leads to your solution when you're done. Now this came up quite a bit on this problem, and I saw a lot of people doing this. All of a sudden we had this x plus h, that quantity cubed, and people, oh, woo, we just went and we were able to expand that in our head. My question is, how do you do that? Did you use binomial theorem? Did you use an application of the triangle, which is known as Pascal's Triangle? Somebody could have maybe done that to show how they arrived at that, but you've got to show how you get that, because most people cannot expand a cubic in their head. So you've got to make sure you show all your steps of how you get to your answers. All right, now this person's stuff right here, this is something I see from time to time. Notice up here you've got a y right there and a y right there, and then they factor. What they did is they just said, well, let's just drop the y. You can't do that. If the variable is in the problem, you can't just drop it and then down here just add it back in. So make sure if you have a variable in a problem, you keep the variable in the problem. Now here's another one that has an incorrect statement in it. When you have this log base 10 of 70 minus log base 10 of 70, you can't write it this way. Okay, that's an incorrect application of your logarithmic rule. So if you need to review those, be sure you do, but that's not the correct way that you should write that. That would be written as log. Now you can write base 10, but you don't have to, and then 70 over 7. That part is what would get grouped together. All right, so make sure you know those rules. Now here's another one. Again, just be really super neat, because this right here kind of looks like a 20 over 7 or 20 over 2. So make sure your writing is neat and organized. And I don't know where this came from, that 10 right in there, and then so I guess it's 10 to the exponent of log 10. It's not very clear. So again, be clear with what you're communicating. Okay, here's another problem right here. Let's first take a look at C. I don't know, do you go this way to start with, or do you go down to start with? Who knows? Can't tell. And then where's their final answer? Because you've got this piece right up here, which is in the blank, but where does that come from? I don't know how to follow this or which way to go. So be clear with what you're writing. That's why I asked for you to do all of your work on a separate sheet of paper. Now let's take a look at E on here. E is one where a lot of people made some mistakes on this. Here, again, hard to tell if you go down first, you go across first. I can't really follow along with what this person's doing. And then, you know, little technical things like all of a sudden we forget the parentheses here. So be sure to tighten those things up. Now, their answer has a minus right there and a minus right there also. Here, it's kind of hard to tell, is that just part of the line or not? So again, be clear with what you're writing. Now, here's a problem that a lot of people made on this, mistake that a lot of people made on this problem. So they correctly were looking to get the common denominator, which is awesome. Here's the mistake. If you have a minus sign right there, just be really careful when you do combine it to have one numerator, that you put parentheses around that part. Because based on what they have written right here, this part, where does that negative sign come from? Because if these parentheses aren't here, and all you have is this plus HA, then this guy right here should be positive, not negative. So again, I know that you were going to be subtracting that. Your brain was just thinking so fast, that's why it made that mistake. So organize using parentheses. It totally helps, and you won't make that mistake there for this type of problem. Again, here's another one where it's like, ta-da, I can expand all that in my head. Yeah, I don't think so. Ooh, this is a neat one too, so check this out. So on this problem right here, the way that it's written, it looks like each one of the new denominators are being multiplied by what is circled in red. And really, it's the numerator and the denominator that are being multiplied by what's circled in red. So write what you mean and mean what you write. Okay, they do a really good job through the rest of the problem down here, but it's just that one piece right there. You would multiply the top and the bottom by x, because that's what's going to end up giving you. If I take a look at this product right here, that's what's going to give me that part on the bottom. And then the same thing over on this other piece. This piece right here would give me that on the bottom, but there's nothing written in the numerator here to come up with anything other than the 3, or right up here to come up with anything in the 2. So again, notationally, make sure you show your work correctly. oh, this looks so great and everything. There's just a couple small little things here that need to be tightened up. When you have a problem like this that has a very, very long expression, what you want to do is make sure whatever's in the numerator stays in the numerator. So this dividing by bar, that's got to go all the way over, because that happened throughout this problem all over the place. So again, it's a notation thing, but make sure your notation is correct. Now here's a problem where the student has the correct answer right here, like that is the correct answer, but there's no way that correct answer comes from any of this work. And so when that happens, you can't earn any points because the work that you have does not support the answer that you have written down. So your work must equal the answer in order to be considered for points. Now here's another one where it's kind of difficult to follow. Where is the answer? It's just kind of somewhere in there. So please take your time and organize your work. Here we are with another neatness issue. Is that a 25? Is it a 20? It's really difficult to tell. So take a moment. This is obviously written in pencil, so erase it and rewrite it so that there's no doubt. And then this right here kind of looks like a plus or minus. So again, take your time and be careful. Write what you mean and mean what you write. Here's another linkage error problem. Like there's no way to really determine how all of these things are linked, because the way that this is written right now, it's like this piece right here is being multiplied by this piece right here, which is being multiplied by this piece right here, which is being multiplied by that piece right there, and it's set equal to all of that. So you've got to be clear in how you are linking things using correct order of operations and use of equal signs. So make sure your notation is good so that you don't lose points for linkage errors. Now here's something that comes up all the time when people want to use slide and divide. So these three pieces right here, like this is the same as the first one, so that's okay. That's okay. But when you take a look at this version and this version, neither one of those are the same as the original problem. Now this person recovers and kind of does that correctly right there. But take your time when you do that, because when you're using slide and divide, that's a technique that is very, very risky with that. So if you're going to use that, you're taking a chance. But at this level, you should be able to factor correctly without using slide and divide. Now this is going to be a really nice example on the use of parentheses right here. Now I like to refer to some of these parentheses here as what I call big beefy brackets. Now let's take a look at this line right here, the one I want you to take a look at. Now if you count, so think of those of you guys that are in programming, so we've got 1 there, 2 there, and 3 there. So if I have 3 parentheses that are all going this way, I should have 3 parentheses that go the other way. Now if I count, I've only got 2 sets of parentheses. So when you do that, make sure that you have the same number of parentheses going in as well as coming out. So where's the issue on this one? Where's the issue on that? Because I've got this one right here. So what I like to do is use the big beefy bracket and then put 1 at the end, like that. This 2x squared is being pulled out of those first 2 terms, and then the -1 right here. So I'm going to go rainbow color on that. This guy right here is what's being pulled out. So take your time and use your parentheses correctly. And so, because we're going to get into some more complex ones later that are going to have a lot more parentheses in. Now, in this particular problem, this came up quite a bit. And when you solve this problem, you'll end up with 2 possible solutions. You'll get a 0 and you'll get 4. So when you do your algebra to go through this, you've got to make sure that you show x equals 0 and then x equals 4. Because both of those are what are called as candidates. And later on, when we do some things with derivatives, that's going to be a key point when we talk about those. Now, that doesn't mean every candidate is a solution. It just means they're possible solutions. And of course, this person does a great job down here showing, as they go through the check, they're like, okay, they put in 0 and they identify it as being extraneous, which is great, but you've got to make sure that you at least identify it as a candidate, as a possible solution. So make sure that you do that, and then if it is extraneous, then identify it as being extraneous. Now this happens from time to time on different problems. You'll have this piece right here, x squared, and then the person correctly factors that from the rest of the terms, but then all of a sudden that x squared goes away. And what they did, basically, is they divided this side and this side. They divided both sides by that x squared to get rid of that. And when you do that, you lose one of your solutions, because if you would have left that in there, so x squared, put a big beefy bracket around all that, and then x squared there, what you end up with is your missing solution, and that's x equals 0. So make sure that you don't divide both sides by that x squared term, because then you miss one of your solutions. Oh yeah, we had some physics homework in there, so that's pretty cool. I was glad to see that. All right, learn a little bit of physics stuff. So keep your math stuff and your physics stuff separate, so when you turn in your math stuff, like, it's just math. Now here's another one where here's the correct solution right here, but if I take a look at all of this work, that work does not support that solution. Here's a really good example of something that we'll talk a little bit more in detail about. I want you to take a look at this piece right here and this piece right here. Now, this one is done incorrectly. This one is done correctly. Now, what happens with that is that in AP Calculus, what they do is they will add the points together that they've earned for that. So if this one they didn't earn any points, and this one they would have gotten the full point because it is done correctly. And so what they do is they average that together. So you would have 0 plus 1, and then divide it by 2, and you get 0.5. Then instead of what they do is they'll truncate it and round it down. So even though you would have had half a point, when that gets rounded down, then that goes to 0. So that's just a little bit about AP style grading and what happens if you show correct work and incorrect work, how they will grade that. So they'll average it and then truncate by rounding down. And then of course here for this other piece, the 16x squared plus 4, nothing is shown there, so no points for you. And I think that might be it. Oh yeah, then we had a little bit of help here, I guess, from Justin. So glad you guys are collaborating with each other and working with each other. But do take your time and come in to see me anytime you've got questions. But please don't wait till the last minute. That's key for this. Because what does AP stand for? All right, I know you guys are going to clean up some of these mistakes. I mean, it's just little blips along the way. And I know our writing and our communication is going to get much better as we go throughout the year. So that's it for this. Make sure you make any corrections you need to, and I'll see you guys soon. Peace out.